y'all did yesterday. So geometric mean in general is when your cross product is something the same, so it's a square, which turns into x squared equals ab, and so x equals the square root of ab. So there's that version of geometric mean, but then for the triangle part, which is part of yesterday, when you have a triangle, so you have a right triangle, and when the altitude is drawn from that right angle, it creates a total of 3 triangles in this picture. With those 3 triangles, it then creates 3 different proportions. So how they're set up, this is your altitude. You have 2 legs of your large triangle. You have a long leg and a short leg. One of them is leg 1, the other is leg 2. It doesn't matter which one you call leg 1 or leg 2, but whatever you do call leg 1 affects what you call segment 1. That was part of yesterday. So if we call this one leg 1 and this one leg 2, the longer leg goes with the longer segment. And the longer segment are the 2 parts of the hypotenuse created whenever you have that altitude. So this would be segment 1 and this would be segment 2. And then you have the whole thing of your hypotenuse. So with the geometric mean, we have that proportion of x over here. With your triangle, there are different parts of that triangle that take its turn having that relationship. There's one with your altitude, where your altitude is that mean, geometric mean, and then there's one where your legs are geometric mean. There are 2 different legs, which means there's going to be 2 different proportions, whether it's with leg 1 or leg 2. That's where the 3 are coming from. So this part that I labeled, like how it's labeled that pink part, especially today, I would say maybe go through and like every picture that you see, label that. It's just helpful, especially like on a test or a quiz. Like it's just helpful to label that part to help figure out what proportion you should be using, what all of that is. Also keeping in mind, these are going to be 3 right triangles. So yes, you can always use these proportions, but sometimes you would need maybe Pythagorean theorem to solve something along those lines, and those could also be used. Yes?
Is the triangle you're using always going to be right triangle?
Yes. These are similar right triangles. Yes. For geometric mean. Okay. So first, just geometric mean in general, we went over it. It is this proportion, which means it is x squared equaling ab. So x, the geometric mean itself is just the square root of the 2 other numbers. So when it comes to a problem like this first one, find the geometric mean of 12 and 24. What that is saying is that we don't know what number that is, but here's your setup. Therefore, x squared equals, what, 288? Which means x is 12 root 2. That's what you're doing if you're just given, like, what does geometric mean? Truthfully, you probably could just even shortcut going straight from here to there if you wanted to, instead of setting a proportion. Just multiply the 2 numbers together, whatever it is. The other option is if I give you the geometric mean, so 8 is the geometric mean between 6 and what other number? So meaning 8 is your number here, and then it's with 6 and what other number? So now you're just solving a proportion. 6 over 8 could just be 3 over 4. So 3x equals 32, and x is 32 over 4. So those 2 options when it's just the straight up left numbers. The rest of our practice today is all with the triangle stuff. So with the triangle stuff, we went through this already, so we're going to kind of go through it yesterday. You have a large triangle. When you draw that altitude, it creates a medium and a small triangle. So there's a total of 3 triangles. We also talked about it yesterday. They are similar triangles because of angle-angle similarity. So we got that part. That's where that is coming from. Okay. You want to know where that's associated. So now going through, knowing that we have similar triangles here, we have angle D, angle F, and then we have our right angle. We have the large triangle of triangle DEF. We're going to write the similar triangle. So we have the large triangle, we also have a medium triangle, and we have a small triangle. Here's the large. We'll fill in the medium, and then we'll fill in the small as well. I'll give you a second. What would those letters be for the medium and the small with the parts, like the similarity statement written correctly, correct? Parts. So then, full screen. Okay, we've got proportions to fill in. I want y'all to try them. So you have BG over EG, so it's the two legs of the smaller triangle, and so it's the short leg and then the long leg. And then if you look at for E or F, GF is the long leg, so you need the short leg, so EG. Okay. Do I get the second one yet? We have DF, which is the hypotenuse of the large triangle, over EF, and then you have EG. EF is the longer leg of that large triangle, so if we have the long leg here, that means you need the hypotenuse of the shorter, the smaller one, so DE. Should be in that box. There are proportions. Now let's get to our theorems and solving problems today. So, theorems and solving problems. Our three theorems, it's technically two theorems, but we get three proportions out of it. So, first theorem is our geometric mean when it's the altitude. So when the altitude is our geometric mean, it is using the two segments of the triangle. When the leg is the geometric mean, there are two different legs on that large triangle. You have the short leg and the long leg. Because you have the short leg and the long leg, that's how you get two different proportions. One uses the short leg, the other uses the long leg. So, how I tend to write it, instead of like these ones, thinking about X and Y, I go back to the picture that we had in the beginning. We have our altitude, leg 1, leg 2, segment 1, segment 2, and then our whole hypotenuse. Those are our labels for all of our large triangles, whenever we're looking at these similar triangles. The altitude mean, when your mean is the altitude. The means are your altitude. The extremes, so the other two, are the two legs of, or the two segments of that triangle. So segment 1 and segment 2. So it's the two smaller parts created from that altitude splitting the hypotenuse. Okay. The other two involve the legs. So you have leg 1, or you could have it with leg 2. When it's your leg, one of your extremes is always the hypotenuse. The other part of it is the segment, which is adjacent to it, which is so like right next to it. So if it was leg 1, then you're using segment 1. Leg 2 goes with segment 2. So those are our three proportions. Depending on what's given to you is controlling what proportion you use for each problem. So if they give you enough information to set up whichever one of those three, that's how you justify or that's how you know what proportions you solve with. So it's going to get better once we go through the problems. So going through this one. First thing I do, especially like in the beginning, just go through, here's our A, there's our leg 1, here's leg 2, here's segment 1, here's segment 2, and our hypotenuse. And then also just writing our different options. One of our proportions uses the altitude. And when it uses the altitude, it uses the 2 segments with it. One of our all right. So there we go. Go through altitude, leg 1, leg 2, segment 1, segment 2, and this is our hypotenuse. I'm still going to write out all of our options. We have our leg 1, which uses our hypotenuse, and segment 1, or leg 2, hypotenuse, and segment 2. Okay, so those are our 3 options for our 3 different proportions. We need to solve for x and for y. What are we thinking?
First, we're gonna solve for y. Wait, where's x? Oh, wait.
Okay, we could use that first one, the altitude one. Altitude is 6. Do we have numbers, or so how could you write segment 1? This could be written as y minus 4, right? So we could do that. So if we use that first one, that would mean we have y minus 4 over altitude, which is 6, equals 6 over segment 2, which is 4. So we can solve that for y. Y is 13. That's good. Okay, so now we know our hypotenuse is 13. Helpful. That also means that this segment 1 would be 9, right? So now we're solving for x. X is leg 1. Do you have enough information to just use that proportion, like the leg 1 proportion, the middle one? Do we have a hypotenuse? Do we have a segment 1? Yep, we have numbers for both of those. Okay. Then that means our hypotenuse is 13. Leg 1 is x, and segment 1 is 9. Instead of, have y'all ever done it this way? Instead of actually multiplying 9 times 13, 9 is a perfect square, right? Does 13 have any perfect numbers inside of it? It's prime. So instead of actually multiplying them together, if you do it like that, it's like, you can automatically know that it's just 3 root 13. Instead of multiplying them to get whatever 13 times 9 is, it just shortens the simplifying step. Because if you multiply and get 117, then you have to have the square root of 117, which is just undoing the multiplying that you just did. So, little trick. Okay, how do you feel so far? Honestly, as long as you just keep those proportions, like the better you just know those proportions, the faster you can get. It's just more practice. Like that's what today is. Like if you just keep practicing it, it'll start going faster. Annoying, I know that we have to just do a bunch of practice and problems, but that's the only way it gets faster because it's not, it doesn't get terribly hard. Okay. Next part. We have our picture going through. Here's our leg 2, leg 1, segment 2, and hypotenuse. All of our different options. We can have our altitude. We can do it with our legs. Number 6 is separate from number 7, so when we write numbers for number 6, we erase it again for number 7. I want y'all to do 6 and 7. Try and do 6 and 7 without me. See how getting some on your own goes. Okay. We're going to skip the other two, or the rest of the ones on here. We're going to go to the next set of problems. Okay. On the next set. This, I know it's labeled, this is the letter D. I don't know. The A's and the D's kind of confused me earlier. When I first was doing it. So, I want y'all to try some of these without me first. I want y'all to at least look at them and try and get a bearing first before we do them together. So, try these ones. You should be able to get a few of them done. Maybe all of them. And then we'll come together. Okay, let's look at the first one. I have it all labeled up here. What proportion should you use? Segment 1 and segment 2 with your altitude?
Yeah.
Yep, okay. So that would mean root 6 is your mean because that's your altitude. And then you have 2 over x. Root 6 times root 6 is just 6. So that's 2x equals 6. So that means it's 3. The second one's a little bit more challenging. Throws it up a little bit. We're looking for AD, which is a segment. Segment is used in altitude proportions and the leg proportions. What are we getting information on? A leg or an altitude? Do we have altitude? We just have a leg, which means you have to use that leg proportion, where 8 is your geometric mean. That is our leg 2, which means we need the hypotenuse. How could you write the hypotenuse? And then x for your segment. So that's solving a quadratic. You've got x squared plus 12x equals 64. What factors multiply to be 64 by
Negative 4 and 16.
Yeah, so positive 16 and negative 4. So that means our two options are negative 16 or 4. Therefore, 4. This is the one.
Is this on the side?
No. Cumulative won't have chapter 8. This is this first section of chapter 8. Cumulative is just 6 and 7. Okay. Last one involves a ratio. So the ratio of BD to AD is 2 to 1, and then DC is 8. So we got 8 here. How do you write it with the ratio part? 2x and 1x. So BD to AD, so we have 2x to just x. Are we using a leg or an altitude proportion? Altitude, because we have an altitude of 8. altitude. The other two that meet the extremes are the legs. Or sorry, not the legs, the segments. So x and 2x. So 2x squared equals 64. Okay there? So x squared is 32. So x is the square root of 32. Which means x is 4 root 2. 32 is 16 times 2. Okay. On the last bit, we're going to jump around again. Oh, no, we only have 2 more. Okay. So the next two are getting a little bit more like of a complicated version of it. Oh, do you get 3 more?
It's just like,
How?
doesn't look like a question.
Yeah, it's just the ratios. Oh, my gosh. Is this on your desk?
Yeah.
Oh, interesting. Okay. All right. Yes, we only have 2 more questions. So here's our problem. We need to solve for y. Altitude, leg 1, leg 2, segment 2, segment 1, and hypotenuse. We're solving for y. Is our altitude labeled? Okay, so the chances of us needing to use an altitude proportion are slim to none, since it's not even labeled. So that means we're probably using a leg 1. Okay. Well, if we are using, we have a leg 2 labeled, that means this is our proportion. Fuzzy. So that means we now have to go through and fill in with the information we have from the picture. How could you write the hypotenuse? 3y minus 1. Leg 2 is y plus 1. Y plus 1. And then segment 2, which is y minus 1. Which involves multiplying these things now together. Do y'all remember how to multiply binomials? Sort of, kind of. Okay. 3y has to multiply with both of those parts, so that'd be 3y squared minus 3y, and then negative 1 has to multiply both of them, so that's negative y and plus 1. So 3y squared minus 4y plus 1. That was just that. Now we're doing the other direction. Y plus 1 times y plus 1 would be y squared plus y plus 5 plus 1. So y squared plus 2y plus 1. Now we solve it. Throw it all to one side. It's quadratic. You got to solve. So it's 2y squared minus 6y equals 0. You good with that so far?
Yeah.
Okay. Both terms have a y, and both terms are divisible by 2. So that means we can take out a 2y, and we'd be left with y minus 3. Two answers here. First part gives us y equals 0. Second one, 3.
Wait. Wait, how did you get y equals 0?
Every time that you have a quadratic, when you factor it, the two things that are being multiplied, you set each one equal to 0.
Ah,
Right? So then this one gets to the 0. Do both of those work? Because both of those plug back in for y. Y wasn't just a length, it was like expression for the lengths. So does 3 and 0 match for both?
No.
Which one doesn't work?
0.
Okay, 0 doesn't work because this one would be 0 minus 1, so -1 length. Always just double check, because if both of them work, like if your answer was like 2 and 4, the numbers 2 and 4 generate positive numbers for all that. So just make sure you include those. Okay. Oh, there we go. We got one more to go to. On our last one, we have a 12-centimeter long altitude, wonderful, of a right triangle that divides the hypotenuse into 2 segments, one that is 3 times the other. How long is the hypotenuse? Okay, going through and doing all that label. We know the altitude is 12, and the hypotenuse is split into 2 segments, one that is 3 times the other, so x and 3x. So we have an altitude, which means we're using our altitude proportion. Altitude proportion uses the 2 segments. Okay. Are we good with x? The question is now asking how long is the hypotenuse. So the hypotenuse would be 4x, right? Because the 3x plus the x, so multiply our x value by 4. When you multiply that by 4, what do you get? 16 root 3. Anytime you're multiplying with radicals, outside multiplies with outside, so the hypotenuse would be 4 times 4 root 3, so 16 root 3. So the struggle with this is not just the proportion, but also like algebra stuff is involved, radical stuff is involved, so like all of that is potential to screw you as well. All right, we are done with our notes. There is still